Here we are in Chapter 3 review exercises numbers 30 through 37. For the following data set, is this a relation? Oh, this right here, is it a relation? Well, a relation is kind of, what is a relation? Anything. Yeah, so the question is this a relation? Yep. Why? Because it is anything that's relating to sets of data. Lists of cities and temperatures, it is a relation, check. Yep, anything that relates it is. Now, the next question, is this a function? Oh, that's a good question. Now, a function is something where each element of the domain is mapped to only one element in the range. So, in this case, let's look to see if there are any duplicates here. Uh-oh. There's one right there. I see a 59 and a 59. There's another one, 70 and a 70. So that means if this were a function, this 59 were mapped to Springfield and to Detroit, which that violates the rules of being a function. So it is a relation, but it is not a function because 59 and 70 are both elements of the domain that got mapped to more than one thing. And that's not a function. If our calculators did that, we put in 2 plus 3 and got two different things, we would not be impressed. So we separate functions out and say, nope, this is not. You can sit there as a relation, but not there. The domain of this function. So the domain are the inputs here, the first half of every point. So let's see if we can get them in order. 59, 61, 70, 72. Let's go and knock them off when we do them, and so we don't see them anymore. Confusing. 61, 70. We did him. Repeated. 72. Looks like 80 and 84 will give it to us. 80 and 84. So that set of numbers is the domain. What is the range? The range is the second half here. So it is just, you'd start writing it out. You got Birmingham, and then you have Springfield. And so it's just, yep, brackets around there, brackets around there. Write that all out, and all those cities is the range. Excellent. All right, number 34. You are now dealing with three functions, f of x, g of x, and p of x. And we're supposed to find p of -2. So if that means we're doing -2 goes right up in there, that means -2 goes there and there. So we have p of -2 equals -2 cubed minus 2 times the -2 plus 15. See, -2 cubed is -8. -2 times the -2, that's plus 4 plus 15. That's -8 plus 19. That's a positive 11. So if this were graphed, you'd have -2, 11. -2 goes in for the x. 11 pops out for the element of the range that connects up with that. But p of -2 is 11. Good. Number 35. P of 0. So that means we're going to stick 0 in for x. So this is 0 cubed minus 2 times 0 plus 15. Sticking in 0 for x, hey, we get a y-intercept. That's what that means. 0 minus 0 plus 15 gives you just p of 0 equals 15. Excellent. On a graph, that means 0, 15 would actually be a point. Okay. F of, squiggle. That means we're going to stick that squiggle right up in there. So f of squiggle is going to equal squiggle squared, exactly like it says there, and plus 7. That's it. That's what f of squiggle is. 37. Very interesting one here. G of f of x. So we're going to take g, and we're going to take f of x and stick it right in there. Yeah, f of x is going to go right there. So that is going to equal 7 times f of x minus 5 all over 2. So simplify that a little bit more. We know what f of x is. F of x is this right here. So we get 7 times x squared plus 7 minus 5 all over 2. And notice what we did. We took that entire function, f of x, and we stuck it into the g function. That's, wow, that was cool. So this is going to be 7x squared plus 49 minus 5, so that's a plus 44, all over 2. Yeah, and you could leave it just like this. This would have been a perfectly okay way to leave it, or you could simplify it down to that. That would have been all right as well. Good.